Data mining is about finding or learning patterns from the data. So in this video, I'm going to talk about two types of learning that are common in data mining. The first type is called supervised learning, and the second type is called unsupervised learning. So let's start. The first learning type is supervised learning. In this type of learning, the training data is labeled. So this is the keyword for supervised learning, labeled data. And the purpose of supervised learning is doing a prediction or a classification. Now first, let's look at an example of a labeled data set. So in this data set, we have each data in the data set is usually called a instance or an example. Okay, so here we have, I guess we have 10 instance or example. 4, 5, 6, 7, 8, 9, 10. So it is called, each of this row is called an instance or an example. You can think of this as each of this is one fish. Okay, so here we are talking about fish. Okay, and then this characteristic of a fish, they are called features. Some people call them attributes. Also, people call them independent variables. So for a fish in this example, the characteristics that we record are the length, let's say 3 meters long, whether it has gills or not. Gills is something that fish use to breathe, and then whether they have beak or not, and then whether they have many teeth or few teeth. Okay, so these are the features or the characteristic of each fish. Okay, now the last column is the one that we call the label or the target or the independent variable. Here, it depends on the purpose of what we're going to do with the data mining. Okay, so here suppose the purpose is we would like to classify or predict whether a fish is a dolphin or not a dolphin. Okay, so plus means it is a dolphin, minus means it is not a dolphin. So the first fish or the first instance is labeled as positive or dolphin. While, for example, the second from the last fish is labeled as minus, which means it is not a dolphin. Okay, so the label itself can be, you can write dolphin or not, you can write yes or no, you can write 1 or 0. It doesn't matter. It's just a label to distinguish between one type and the other type of fish in this case. Okay, so positive and negative here doesn't really mean that one is better than the other or it has any mathematical sense. No, it's just a label. Okay, it just says that this instance is labeled for sure it is a dolphin. This label has, this instance has been labeled for sure as a fish that is not a dolphin. Okay, so for supervised learning, you need to have a data set that looks like this. For each instance, it has been labeled. Once we have a labeled data set, we may create or we may train a data mining model to find the patterns from the data set. For example, here we have a decision tree, which is one of data mining models. And then based on the tree, we see that we ask whether the fish has gills or not. If yes, then according to this tree, the fish is not a dolphin. Okay, but if the fish does not have any gills, then we need to ask another question about the length. Is it 3 meters long, 4 meters long, and 5 meters long? So that's how decision tree, which is one of the data mining models, can learn from the data set and find these patterns. So here it learns that based on the data set that we have, if a fish has gills, then the conclusion is that here the fish is not a dolphin. Okay, so once again, this is based on the data set that we have. So the result of data mining really depends on the data that we have. So for the first type of learning, which is supervised learning, here is the takeaway. You must have a labeled data set to perform the prediction or classification tasks. Okay, so if you want to classify whether a fish is a dolphin or not a dolphin, then you must have a data set that has been labeled. Okay, every fish in this data set must have been labeled whether it is a dolphin or it is not a dolphin. Now, the second type of learning is called unsupervised learning. Here, the training data is not labeled. But what can we do with unlabeled data? Well, we can do clustering, or we can also find associations based on the data. So here's an example of a unlabeled data set. So here we have the data set of customers. And for each instance, we do have their feature. So the first customer has 5 number of transactions. The total purchase is $450 and their income is $90,000. But then here we do not have any label for these customers. Okay, so in the data set, we do have their features, but we do not have any label for them. So clustering means that we might want to see which customers can be grouped together because of their similar characteristics. Just for example, let's say customer 1 and customer 2, and let's say customer 7 and customer 11, maybe they belong to one group because their number of transactions are small, their total purchase is also relatively small, but they have a high income. For example, it's just an example, okay? So don't look at the numbers. I was just making examples. And then maybe number 2, 3, 5, and 6, they belong to another group with another kind of similarities between them. Okay, so clustering means that from the unlabeled data, we are going to group them, and each group they have similarities, and between one group and another group, they we would like them to be as dissimilar as possible. Okay, so the customers within a group, they are as similar as possible, but with another group, they should be as different as possible. That is the purpose of doing clustering. To visualize clustering a little bit more, let's look at a data two-dimensional. And on the left here is the original data. And then clustering means that we are going to group the data that we think they are close or similar. For example, here is the result for the clusters. So we think these two are similar, these three should belong to one group, and these four belong to another group. Okay, so this is an example of clustering. So here I'm not saying that this is the best cluster, is it good or is it bad? I'm just saying that this is an example of a clustering result. Okay, so we group the data that we think are similar. So the takeaway for unsupervised learning is that the data set is unlabeled. And then using this unlabeled data, we may find groups or clusters from the data. We may also find associations from the data. One of the applications is the market basket analysis, in which we analyze what people purchase, let's say in a supermarket. So we may find out when people purchase this thing, usually they purchase another thing together. Okay, so that is called the associations between those items. And we can learn that also from unlabeled data set. Okay, so in this video, we learned that there are two types of learning, supervised and unsupervised learning. In the next video, I'm going to talk about, suppose we have the output of data mining model, how we can evaluate that model to know whether it is good enough, bad, or we have two models, we can say which one is better. So we are going to see that there are some performance metrics to do that kind of evaluation. In particular, I'm going to talk about the performance metrics for supervised learning. So see you in the next video and thank you.